All right. So the first thing I want to do is take a little 2 minutes and look over all the rules. Right? Screenshot them, have them close. You want to write them over, no problem. I want to have all these rules close there, and we're going to start to prove some identities. Right? Proving identities is basically where we are going to give you an equation and we are to show the left hand side and the right hand side equal. But we have to know all the rules. Right, to make it easy, I'm going to start with the blue square first. I'm going to try to do one with the blue square first. Right? We pay attention to all of those, right? In the blue square. Make sure I'm really won't be behind. I don't know why you know it, but not today. As I said, we're focusing on using the blue. I'll try to tell you which set we're using, right? So firstly, we're starting with the blue. Right, I just want to show you something here. Everybody have it, right? Taking this off. Right. What we have to do now, just pin me down there. Right, so we're starting easy. So again, we need to be able to prove this, right? Whenever you see the three lines mean this is equivalent to this, and you're not supposed to move things around and try to solve it, right? Some people will take the cost on this side, leave a 0 here, and try to show that this is 0. Can't do that. Only if you had 2 lines, then you can start to solve, but you can't solve, right? This is more like an identity. So we have to show that the left-hand side equals to the right-hand side, right? You have to figure out now which side to start with. Whenever you're proving identities, you start with the side with more information, right? If I look here, I would say that the left-hand side has more information, right? Sometimes you can do a cheat and just, if the right-hand side has some information, you can break it down, but focus on the side with more information. That's okay? So if I look at this left-hand side here, I will recognize that this has sine and tan. The right-hand side of cos. So I have to find a way to eliminate sine and tan and bring cos alone. Right? So the first thing I like to do is I don't like to leave it like this. I like to write it like this. Sine theta divided by tan theta. It makes it a little bit easier to simplify. Right? Good. Based on the blue square, what's an identity that we could use here? Right. There's none for sine, right? There's none for sine. Okay. But tan is what? Sine on cos. Right? Tan is sine on cos. So you have sine theta divided by sine theta over cos theta. This divide will turn into multiply, and I flip this over. And now, sine will cancel. And you'll be left with cos theta. Okay? That's basically how you prove identity. It don't be this simple, right? It don't be this simple, but I'll just show you the steps that I take, right? Let's look at one a little bit harder now. Right, let's try one a little bit harder. Right, so I want to do this one with you a little bit. Right now, just take a minute and try and come back. Right. Let's see how we do in this one here. Anybody get rid of it? Huh? Yeah. Right. So how would I attempt this? The problem is number one, I see in it that there's a sign alone here, and there's one fraction here. Here I have two fractions. So I get rid of two fractions and turn this into sign. What do I know about tan? I know that tan theta is sine theta over cos theta. So what would be tan squared theta? Well, I'm going to square this, right? So I'll end up with sine squared over cos squared. That's okay? Yeah. So again, the left-hand side has more information. So I'll focus on the left-hand side. So what is tan squared? Tan squared is sine squared over cos squared plus 1. I don't like how this is looking, but what is 1 over a fraction? The reciprocal, right? So for example, 1 over 2 on 3 is the same as 3 on 2, right? So 1 over sine squared and cos squared is cos squared on sine squared, right? What you would recognize in some of these things, right, is you gotta be able to simplify real good, right? If you struggle with simplification, like turning this into this, then you'll find tricks hard as well, right? Right, when you reach here, you do the usual thing, you find the LCM. The LCM is sine squared. The numerator will be what? 1 by this, 1 by this. So the numerator will be cos squared plus sine squared. Check back the identities and you will see that cos squared plus sine squared is 1. So this whole thing here turns to 1. Okay? Normally, if you're doing it properly, and then it takes 5 to 6 lines, no more than, right? If you do it properly, sometimes 4 and 5 lines. Okay? So if you find this looking like a new one, add it, please. Right? Tan squared. Are you okay with that one line? Borrow? Tie? Right, so I'm going to message, I'm going to give you our next one, and I wanted to message QED to get it, right? So to make sure some of you are there. Borrow you there? Tie message, right? Tie there, Crystalline there. Renisha there, Borrow, Hamlet. This Hamlet going up. Yeah, this one. Then we have 2 of them. Well, 2 of them not in. Whatever. Although it's the same class though. Ready? So just add this to the blue if you're looking blue, right? Add this to the identity. Tan squared is equal to sine squared and cos squared. Right? So remember the same simplification that you use in maths, same thing you use in here, right? Right, let's go. Right, online, if you get this one, message QED, right? QED means that you prove it. I'll give you some difficult ones later on, right? I will start with some easy. Right, they're supposed to be about 2 lines long, 3 lines. Right, if you get it online, message QBD, don't forget. Focus on the left side, break up the little fraction thing, let's see what you get. up first, right? Break it up like that equation thing there, break it up. And then look for the identity. Doing it done. Good. Get there. Unreal second. Again, I think we're not playing money. Have no she you don't have much you have any you don't have bad changes. So what you can let her do on one day that come with another photo. I use that. I don't want to look at it anymore. Okay. Yeah. Yeah. Thank you. Let's see what I think look like. We have two QEDs online. Yeah. All right, nice. 4 QEDs good. Good sign. It also means that to go harder. All right. Let's see what you get, right? So left hand side, I'll break it up one time. I recognize that 1 minus cos squared is sine squared. So I write then sine squared divided by tan squared. Right? I replace this one time. Right? Now tan squared, as we saw earlier, is sine squared on cos squared. Now I could take sine squared on 1, multiply it by cos squared over sine squared. Sine squared will cancel, and I'll be left with cos squared. Right? Nice. So we get in there. That's a good sign. We get plenty of QEDs. I think people like Nathan are going to pop 2, right? Let's make finish it out fast. Again, the ones that given in only in the blue triangle, in the blue square. I'll change the that's now and you have to use the blue and the one on the right. What color that one? Red. This one here, you have to expand properly. Take your time and expand properly, right? And this one here, a little tricky, but this one a little tricky, right? Take your time with this one. Please remember little things like difference, that 2 squares and thing, right? right? Just a reminder, a squared minus b squared is equal to a minus b, a plus. Things like this sometimes is needed. Right? Take your time and simplify inside here and then. Yeah. Right? This one here, just taking your time and expanding it out and you'll be good. But this is not harder. This is supposed to be an easy slash medium. It's light. This one is light. This one, they drop a little more pepper there. So that's medium going to heavy. Take your time. Again, if you get message QED, right? Same way you would expand a normal E plus B or square, do the same thing. I don't know. Because plus square plus n. This is getting expanded some. This alone is not calculated. Plus by sine plus theta sine theta. Plus minus. However, if I never use parts, when you're in downstairs, right? Guy in the downstairs fixing the right? Or the first one, look. Okay, the first one. Yeah, yeah. It's a little bit long, right? But again, you're working on the left-hand side. So you have to expand this out, right? Remember, you're multiplying this by itself, so you'll get cos squared theta plus, I'm gonna show you, cos theta plus sine theta by cos theta plus sine theta. Cos by cos, cos squared. Cos by sine, cos theta, sine theta. Sine by cos, cos theta, sine theta. I could have written it the other way, but it don't matter, right? Because it's commutative. Sine by sine, that's sine squared, right? So that's the expansion of this. I'm going to do the expansion of this one time. I'll end up with cos squared theta minus cos theta sine theta minus cos theta sine theta plus sine squared. What you will recognize is that this will cancel with this will cancel with this. And I have cos squared and cos squared. So that's 2 cos squared, sine squared plus sine squared. 2 sine squared. I could pull it 2 on the outside. I could pull it 2 on the outside and I'll get 2 cos squared plus sine squared is 1. So that's 2. Again, 1, 2, 3, 4, 5. Right? That's okay. Please remember that sine theta by cos is the same as cosine. They're both the same value, right? So these two identical, minus sine, so I cancel them. All right. The next one is a little bit tricky, right? But when you're doing questions like this, take your time and simplify the fraction, right? Simplify this fraction here and then square it. Okay, so simplify inside here, then square it, and I think somewhere along the line you're going to have to use difference of 2 squares. Anybody get this second one as yet? No? Let's pop to see what you do for the second one, right? Anybody get to the second one? The key is simplifying. Simplifying side bracket first. I know, but right? So as I was saying, left hand side, I would focus on simplifying here first. Right? I'll focus on simplifying here first before I start to do any squaring. Okay, I just want to simplify inside here. What would the LCM be inside here? Sine cos, right? So the LCM will be sine theta, cos theta, right? And the numerator will be what? Cos theta minus sine squared theta. Let me make sure I write it down correct. Got my last big one. It's a hard one, huh? I do it. One of the hardest one. One on sine minus. Oh shucks, I write it bad. There's one on tan. Sorry about that. Sorry about that. One on tan. I really find this looking bad. Alright, so because it's my fault, I'll give you a hint. A little help here. Sorry about that. Alright, so try it back here. See what you get. Right here, LCM, there will be sine theta. So put sines. Put your LCM as sine. Right? Again, remember, take your time, find the LCM. The LCM here is sine theta, and the numerator here will be 1 minus cos theta. And you're squaring all of this. You're squaring the top and you're squaring bottom. Right? Take your time. As I said, the one hint I want to give you is that, right? So when you square, you should get 1 minus cos theta squared. And here is sine squared theta. Right? We know that sine squared is what? We know that sine squared is 1 minus cos squared theta. The numerator, don't worry, don't expand it out. You know why? Because you want to get 1 minus cos theta. You already have that here. Yeah, just find a way to get rid of this, right? So this is what? This is difference of two squares. Okay? So the underneath is really 1 minus cos theta by 1 plus cos theta. Right? Because this is difference of two squares here. And your numerator is this. This will cancel with this. And you'll be left with 1 minus cos theta over 1 plus cos theta. Right? You could write QED or Joyle forms. Right? Let's do one more like this before I change it into before I add on the rules in the red box, right? Right, the reason I like this one a little bit is that you're going to have to break down the right hand side. Just about 2 lines. Just break it down about 2 lines and then focus on the left hand side. And take the right hand side and just break it down 2 lines, right? So, right, just to give you a little idea what you're supposed to get, tan is sine x on cos x, right? This will multiply out and you will end up with sine squared x on cos x. And we know what sine squared is. 1 minus cos squared over cos x. So our objective really, actually to be honest here earlier, we could kind of finish it right here. This is 1 on cos x minus cos squared x on cos x. This will cancel. Same thing, right? Or you can use the left hand side and work it out. Find the LCM. 1 minus cos squared x. We know that is sine x, sine squared x, which is technically right here. We can separate it. So you have two ways you can do it, right? Sometimes you break down the right hand side just to give you a little idea. So it's like when you reach here and you know that these two is the same. All you have to do when you reach here now, right, is just to write this line and then this line. So that's the reason why you break down the right hand side. All right, let's change it now and let's use some of the rules on the red side. Yeah. Make sure that this equal to this. So of course, you have to know the identity, right? So go back to the red side and make sure you know it. No? Just expand it out. Just expand it out. Yeah. So just remember that sine 2 theta is 2 sine theta cos theta, right? So we're trying to get 1 plus that. So left-hand side, we expand this already, so this should be easy. This is sine squared theta plus cos squared theta plus 2 sine theta cos theta, right? We expand this in an earlier one. Sine squared with cos squared, that's 1. 2 sine theta cos theta, that's sine 2 theta. That's it. All right. Look at this one underneath here though. The one I'm gonna show you here involves cos 2a. And there's a slight problem with doing questions like this, right? Whenever you have to do questions that look like this, here's the big problem. The big problem is that this is cos 2 theta. Whenever you have to choose an identity, cos 2 theta, you have 3 options, right? You have 3 options. Generally, we don't use the first option. Cos squared minus sine squared. 1% of the time we probably use that. Most of the time we use the one with 1 minus 2 sine squared theta or 2 cos squared theta minus 1. Right? This has 3 options. You only generally use 2 of them. You have to figure out which one to use. All right? So tan is what? Tan is sine over cos. So because tan is sine and cos, it gives you a little hint of what you want to achieve underneath here. What do you want to achieve underneath here? Cos. Right? So which identity you think you should probably try to use for cos 2 theta? The one with cos. That's okay? So that's the problem with questions like this. If you choose the wrong one, you end up with problems. Right? You can still work it out, but it would take much longer. All right? So I want you to try it now. Try this and use the right identity and see what you get. Again, it should be about 1, 2, 3, 4 lines at least. Anybody get it online? Yes. Right? So again, when you reach here now, we have left hand side, right? Sine 2 theta, that's 2 sine theta cos theta. Right? Don't forget to put back your 1. Cos 2 theta is equal to 2 cos squared theta minus 1. 1 minus 1, that's 0. So you'll get 2 sine theta cos theta all over 2 cos squared theta. Right? These two will cancel. And remember, this is cos squared here. So this cos will cancel with the squared. So you'll get sine and cos, which is tan. Right? So what does make identities hard is when they bring this cos to theta. That's complicated because you gotta figure out which one to use. Right? Last one. Last one on me done. Use the right identities and you're good to go. 1 minus cos 2a. I know some of you when you're writing, a 2a looking like cos squared, right? Make sure you separate them. Cos squared, put it 2 higher up. Okay. Right? Choose the right identities and you're good to go. Go up, we'll do some harder ones next week and we try some solving tricks, right? So I spend a little time on that, review the trig rules. We'll do some more again next week. And do some solve. right one, right? Choose the right one. It shouldn't be long. Should be about 2 lines, 3 lines. This. I'll just show you one more time. I'll show you that next week, where you have to magically multiply by something. Yeah, some questions where there's nowhere to go. And you have to magically multiply by something to get the answer. Huh? So like sometimes there's reach points where no identity can help you. So you have to multiply by 1. But if 1 could be sine on sine, cos on cos, tan on tan. It could be something like that. So you have to figure out what to replace 1 with. Yeah. You want something that there's no identity to bring it in. You have to multiply by something. It's a big magic, right? You get this one? Right? What you want on top? What you want underneath? Choose the right one. Choose the right ones and you'll get 3 lines. One's cancelled. Right. Both are not. Who's one cancelled? So, check back in multiplication on top. Right, so you should have this, right? You should have, anybody get it online? This one? Right, because I want, remember, I know that I need to get sine squared A, cos squared A, right? I need to get sine and cos, right? So because I know I need to get sine and cos, I want to replace this with sine. So that's 1 minus 2 sine squared A, top it up, bracket here. Here is 1 plus, right? Bracket here. When I expand this out, I'll get 1 minus 1 plus 2 sine squared A minus and a minus a plus, right? All over 1 plus 2 cos squared A minus 1. Ones will cancel here, ones will cancel here. So I'll get 2 sine squared A over 2 cos squared A. 2's will cancel, and I will get tan squared A.